It's time to dig deeper. NASA has just published a complete set of fresh images of the interstellar visitor 3I Atlas, captured by 8 separate spacecraft scattered across the solar system. And the striking thing is that each instrument recorded slightly different details. This is our sharpest, most comprehensive view yet of an object that traveled here from beyond our stellar neighborhood. Let's unpack what the mission observed, what the frames actually reveal, and what it implies for the ongoing 3I Atlas mystery. Here's how NASA's story unfolds. SOHO registered 3I Atlas as a faint brightening within a noisy field. Minimal structure, only a small glow, but crucially, it confirmed that a coma was present. The object was active, not inert. That first detection showed the body was still releasing material. Next, MAVEN, an orbiter on Mars, recorded an ultraviolet view dominated by hydrogen escaping the source. The bright central spot marks the nucleus, while the expanding blue haze traces a hydrogen cloud spreading tens of thousands of miles outward. That's textbook comet physics. Sunlight warms volatile ice and liberates hydrogen. Nothing supernatural, just well-known processes at work. But MAVEN did something particularly useful. It separated hydrogen by velocity components: Mars, interplanetary hydrogen, and the cometary source. That small blob on the left is 3I Atlas, racing past Mars at tens of kilometers per second. The measurement cleanly confirms its motion. No odd accelerations, no unexplained kinematics, simply a fast interstellar visitor traversing the system. Yes, a Mars surface rover even imaged it. From another planet's ground, 3I Atlas appears as a faint, moving smear. That observation lets scientists triangulate position and refine orbital solutions with remarkable accuracy, the first time an interstellar object has been photographed from the surface of another world. HiRISE, one of the sharpest planetary cameras ever flown, locked on when the comet was roughly 19 million miles away. The frames show a bright coma with faint feathering aligned with its direction of motion. No evidence of splitting, no companion fragments, merely a single stable nucleus cutting through space. The scale indicates a coma on the order of hundreds of miles across. NASA's Lucy mission also caught the object, a clear coma and a subtle gas tail drifting to the right. Even from some 240 million miles out, the tail is visible, strong confirmation of outgassing and directed flow consistent with a comet warmed by the sun. Punch recorded a compact, clean tail and daily motion across the background stars. The tail is small but persistent, again matching normal cometary behavior. Because the telescope was tracking the comet, stellar backgrounds streak in those frames, producing a colorized stereo image where 3I Atlas appears as a fuzzy bright orb surrounded by a textured field. The fuzziness is the coma, the brightness indicates activity higher than anticipated for that phase. Psyche, the mission en route to a metal-rich asteroid, observed the comet over an 8-hour window from about 33 million miles away. Those observations are pivotal. They capture the coma clearly and dramatically reduce uncertainties in the orbit, far beyond what Earth-based instruments alone can do. Put all these perspectives together, and the portrait of 3I Atlas snaps into focus. The nucleus remains intact, the coma is active, the tail is present but modest and steady. Hydrogen emission behaves like a natural comet, cross-mission tracking converges on a consistent orbit. No fragmentation, no exotic propulsion, no clear anomalies. By these metrics, it's acting like a comet, albeit one that originated around another star. This release from NASA is the largest, most varied collection of interstellar comet imagery ever distributed. Mars orbiters and rovers, Psyche, Lucy, SOHO, Stereo, Punch, the entire fleet contributed. And remember, this is only the first tranche. The high-precision, thoroughly processed datasets are still forthcoming. About those rumors, NASA addressed them head-on. Their assessment, the observations show no evidence of engineered structure, no anomalous accelerations, no geometric patterns suggestive of artificial design, no transmissions, just cometary behavior. That said, the chemistry looks unusual compared with typical solar system comets. Are they hiding something? Based on what's publicly available at the moment, there's no smoking gun evidence of anything other than natural processes. Everything released so far adheres to known comet physics. Still, it's only the third interstellar object humanity has ever sampled with modern instruments. And far more data is still en route. So yes, remain open-minded. If anything unexpected turns up in subsequent releases, it will show up in these next waves of processed data. Stay tuned, stay curious, and I'll analyze every new image as it arrives. But here's where things get even more interesting. Even though everything released so far points toward natural comet behavior, scientists are already preparing for the deeper analysis phase, the part where subtle patterns, faint spectral signatures, and ultra-fine structural details begin to emerge from the noise. This is the stage where surprises tend to show up. Not because something artificial is hiding in the data, but because interstellar objects often carry chemical fingerprints that don't match anything native to our solar system. With 3I Atlas, that's precisely what researchers suspect may come next. Unusual isotopes, unfamiliar dust ratios, or temperature-dependent outgassing patterns we don't typically see in local comets. None of that implies artificial origin, but it does hint at a completely different formation environment, maybe around a cooler star, a more metal-rich region, or perhaps within a protoplanetary disk that evolved far differently from our own. And that's part of why the scientific community is buzzing. Not because they expect a spaceship, but because this is a sample of another star system drifting right through our backyard. Its chemistry is a message from a place we will likely never visit. Its orbit is a signature of whatever cosmic event ejected it. Its shape, spin, and activity encode the history of a world we've never seen. And the upcoming data releases might finally let us decipher some of that. The second wave of NASA's analysis, the properly calibrated, deeply stacked, high-precision reductions, will reveal extremely fine details. The density profile of the coma, subtle jet structures, microscopic variations in hydrogen emission, and perhaps even hints about whether the nucleus is oddly shaped or rotating in a complex pattern. Stereo imaging will be able to map its three-dimensional motion through space. Ultraviolet and infrared spectra will expose the exact volatiles boiling off the surface. The long baseline orbital triangulation between Mars, Psyche, Earth, and deep space missions will tighten the trajectory down to astonishing precision, giving us a clearer picture of the comet's past and future path. And once that's done, we will know where it came from, not vaguely, but down to a probable stellar neighborhood, maybe even a candidate star. That is why this object matters, not because it's hiding secrets, but because it is a secret, a messenger from a system that might have formed billions of years before ours, a frozen archive of alien chemistry drifting across interstellar space until gravity nudged it toward us. So yes, the safe conclusion is that 3I Atlas is a comet, but the deeper truth is this: even a normal comet from another star is anything but ordinary. These next releases could tell us about the temperature of its birth environment, the mix of heavy elements around its parent star, the radiation it endured, and the violent encounter that tore it free and sent it wandering for eons. We're studying a relic from another solar system without ever leaving our own. And that makes 3I Atlas one of the most important natural visitors humanity has ever observed.